I'm sorry, 1 mod 35. One, because we're talking multiplication. So in the normal integer world, well, not many things have inverses, but in the rational world, where you have fractions, 3 halves has an inverse. Its inverse is the number such that when you multiply by 3 halves, you get 1. It's called a multiplicative inverse. And so that's this number, x. And we know, of course, that x has a rational representation as 2 over 3. But this is kind of the same thing, except you're in this world of integers mod 35, which has only 35 numbers in it. It's a finite world. And so you want this number k that has that property. Now what does it mean for that to be congruent mod 35? That means that 8k minus 1 is congruent to 0 mod 35, right? And that means that 8k minus 1 is some multiple of 35. Say m times 35. So doing some equation manipulation on that, you get 8k, I guess, minus 35m equals 1. And you see, you need to make your Euclidean numbers k and m. K and minus m, I guess, such that 8k plus 35 times minus m is equal to 1.
Which is your linear combination.
Right, and those are your numbers that you get out of the algorithm that finds the pairings that okay. 8a plus 35b, let's say. You had this theorem somewhere that says you can find numbers a and b for this if and only if 8 and 35 are relatively prime.
Right.
So the greatest common divisor of 8 and 35 is 1. And we can see that pretty readily by the fact that 35 has got prime divisors 5 and 7, and 8 has prime divisor 2, and those don't have any in common. So they're relatively prime. And therefore, these numbers a and b must exist. There's an algorithm for calculating them in there somewhere. And you need to find a and b. And the b is the one that's going to turn out to be the multiplicative inverse of 8. Actually, it'll be minus b, but whatever. Mod, what do they usually use for base? B, M?
A base B and mod M is what they...
mod M?
M, I believe, yeah.
A has a multiplicative inverse mod M if and only if A and M are relatively prime. And we know that A and M are relatively prime if and only if there exists your numbers, I'll call them now P and Q, such that A times P plus M times Q is equal to 1. And so the multiplicative inverse is determined by these P and Q. The multiplicative inverse of A is really going to be P. And the Q is just the number of multiples of M that it takes to drag the whole sum back to being in the range 0 to M minus 1.